One, two. Hello. Three. Oh, we have three. Working. Hello, ladies and gentlemen, dear members of the jury. My name is Mats.
My name is Raid.
And we are here from the science show Kvark.
You know, the sound that duck makes?
Quack, quack. So it should be quite easy to reproduce. And today, we want to talk about the bus.
The bus.
Yeah, not the school bus or a travel bus. The bus sitting on your shoulders right now. You see, air around us applies pressure. And when you take a regular person, on top of them, there is air that weighs as much as a bus. So technically, on top of every single one of us, there is a bus. Now, to demonstrate this, we're going to put some water into a glass. And if we take this glass, and we turn it, maybe take the other glass. Oh, you want to take this one? Okay. Now, if you take this glass, and we turn it upside down, we can demonstrate that air pressure is not only coming from down on us, but it also pushes up on us. So, if we have a glass of water, and we place a coaster on top of it. A coaster is 10 by 10 centimeters, so the air force pressing down on it is approximately 100 kilograms. A big man, like Raid. And now, if you take this glass, and really carefully turn the glass upside down, what happens is we can see how air is not only pushing down on the glass, but it's also pushing up on the coaster. So if I take my hand from underneath the glass and I take my hand away, the coaster stays.
Wow.
And that way we can see that air is also pushing up on the coaster. But it's not that simple. You see, on top of here, there's also some air, so that should push down, right? You saw when I turned the glass upside down, some of the water came out. Which means that the volume of the air up here got bigger. So it is not as dense as the air outside. Which means that air pushing up on the coaster has more force than the air pushing down on the water. And that's why everything stays put.
But what if you remove the coaster? Will the air still stay in? Will the water still stay in here?
If you take the coaster away, air pressure should still remain, and it should push on the water and it shouldn't come out. But still, the water comes out.
So how could we make an experiment where the water stays in there? Maybe if we shrink the glass, we make it tighter, smaller, just a little bit.
Here I have a smaller glass. Let's say it's about a tenth of the size of the other one. And I'm gonna put some water in this one as well. But I'm not gonna pour it in since both ends are open. I'm gonna have to hold one end closed. And I'm gonna put it in. You can see that water kind of stays in, but it doesn't fall out immediately. So there is something going on here.
So what if we would go even smaller with this tube, and we would use straws? Just like we used the glass here, we just went smaller, and now we have straws. I'm pretty sure every one of you has tried it at home. If you put a straw into water, and your finger on top of it, it stays in here.
And when you remove the finger, it falls out. That's because the air pressure on both sides of the water is equal, and the gravity pulls the water down. But now, there must be some magic here, because we don't have a coaster underneath the straw anymore. It's just empty, but the water still stays in. Now, our extensive research has shown that the effect is called surface tension. The water's property to stick together or stay together, but the effect is quite small. So over a bigger tube, if you try it, It has some effect, but it's not enough to keep all of the air inside. So we can try if instead of this one peak tube, we have many small tubes.
Those are a bit too long, maybe. If we take some shorter ones, and we use those to fill the larger tube, then we should be able to make the same effect appear here again. So we put 4 straws into the bigger straw, which means that the water has more effect to use its surface tension. Let's try once more. We saw that the water stayed in there already.
And if I release it, the water comes out. So we see that if the gap is small enough, water won't go through. The bonds are strong enough so they don't fall.
So what if we take a lot of straws and we would just cut it from here? We would get such circles that are basically a mesh of a lot of straws. And if we use this mesh to cover any larger cavity, we can produce the same effect that we had there. So we have a bottle that has one of those meshes on here. Can you show it, Mike?
Yeah, I can.
So the water goes in, the water comes out.
You can show it to the camera, right?
Yeah, yes.
Light.
So we have a lot of straws here, and if we fill it with water, yeah, I think that's enough, we can achieve the same effect. So right now, a bit of water wants to come out, and if we gently remove the coaster, water stays in the bottle.
The surface tension between the water molecules is enough to keep the water in. But if you break the equilibrium, the water still comes out.
So, now we have talked about surface tension and air pressure. And now comes the moment where we have to make a decision. We either pick the blue pill or the red pill. And I think to make this decision, we need a volunteer.
And I say we picked a person all of you have seen already. Definitely the most sensible. Rebecca, please come with us. And we also heard that you are a local YouTuber, so if you can bring your camera with you, it would be great. Yeah, bring your camera with you so we have more angles and you can upload it later.
So we're going to use those little blue pill here and the red pill here. Now, you have a choice between two colors, 2 pills. Would you like to pick a blue one or a red one?
I haven't seen Matrix. Is it worth?
It is a reference for Matrix, but we're gonna hint you that go with red.
Okay.
What a great decision!
I don't know if I should have trusted you.
So, let's just go over what would have happened if you had decided to go with a blue. We have the water here, and blue represents the comfortable lifestyle. You choose what you already know works, and you don't want to discover any further. So we know that when we turn it upside down, I'll come here right over your
Oh God.
Because you know what's going to happen.
Tropfen abgekriegt.
You know what's going to happen when I remove my hands.
It should stay, I hope, in the glass.
So everyone ready? 3, 2, 1. Great. So we all knew that this is going to happen. But what if you go with the more interesting blue, red?
Red represents in life what is curiosity. You see, when you pick red, you're curious, you want to know more, and you use the knowledge you have to research further and to understand how the world works. So Rebecca, please come here, stand here right in front, take your camera with you. Yeah, take your camera with you, get it right so that get the emotion.
Selfie style.
Yeah, selfie.
Good.
Very good. And take one step forward, if you may. Oh, thank you. Now everybody can see him, her, I hope. And now, all right, please.
Yeah, maybe. So we're gonna go with the same experiment. You already know what's going to happen. I'm just gonna put it on top of your head, and then I'll remove my hand. Maybe, Mats, you wanna take the camera?
Okay,
maybe it's a better angle.
I'm gonna take the camera.
Okay, so.
Jetzt kann ich nichts mehr sehen. Eben konnte ich noch gut kontrollieren, was hier über mir macht.
So you know that when I hold the coaster and I put it on top of your head, no peeking, then it's gonna stay there. Okay, so let's try it.
So Ride has his hand right now under the coaster. And now once he removes his hand from the coaster, I'm gonna count down. I'm gonna go say 3, 2, 1, and now Ride took his hand off the coaster. Are you feeling wet yet?
Do I have to do something?
No, you don't have to do something. Are you feeling some water on your head?
No.
Are you feeling curious? You can now look up. And as you can see, the water stays in the glass. And now using prior knowledge that we have on surface tension and everything else, every single one of you here in the audience should be able to figure out why exactly the water stayed in the glass. Thank you, Rebecca. I'm going to give you back to your camera. Let's give a big round of applause for Rebecca. And for the curious minds that want to know how that water stayed in the glass, think about what we taught you earlier and go back home and send us an email.
Thank you.